Our eyes are very sensitive to motion. We can see tiny movements with our eyes even when it is just in our peripheral or side vision. Usually, we define motion as the change of position of an object in a specific span of time relative to an observer. In our definition, we have mentioned two important terms that we will highlight to understand the concept of motion. Let us encircle the word position, which we defined as a point or space. In physics, the common symbols we use are x, y, z, or even d. But in this lesson, we will be indicating position as x. Secondly, motion requires time. Let us encircle it, which we know that is important for anything macroscopic object to reach a specific point without elapsed time. The time is also our first motion descriptor. It is a quantity that describes when an event took place. And again, we measured it in terms of seconds and usually noted by symbol small letter t. The second motion descriptor is distance or displacement. From what we learned in our previous discussion, distance and displacement are two different quantities. One is a scalar and one is a vector quantity. Again, can you identify which is the scalar quantity between the two? Great! Distance is the scalar quantity which describes how far an object has traveled. We can also say that it pertains to the total length traveled by an object in motion, whereas displacement is a vector quantity. And since it is a vector, you will notice that its symbol has an arrow above it. We define displacement as the length and direction of the line that connects the initial position to the final position. Basically, it is the how far an object is from initial position. We can deduce from the definition that distance is always greater than or equal to the displacement. These two quantities can only be equal if the object in motion travels towards one direction only and does not go back to its original position. It is not enough to describe an object's motion just by providing its distance and displacement. Thus, we have to come up with quantities that combine of time and space. And you are also very familiar with this, speed and velocity. You see, these quantities are usually used incorrectly in most cases. Let us check your background knowledge about it. I have two definitions here. Which one do you think describes the speed? Correct. The speed is the rate of change in position, which we denote by the symbol v or s and a unit meter per second. On the other hand, a velocity is the rate of change in position with respect to a reference point. This phrase, respect to a reference point, is so important because it tells us that it is not enough for velocity to be expressed as a magnitude or number only, but it needs to be supplemented by direction. Therefore, we use a vector arrow on top of its symbol, but it has the same unit as a speed. Mathematically, we define speed as v is equal to d over t, where d is distance and t is time. Conversely, we can mathematically show the definition of velocity as v is equal to displacement over time. Last in our list of motion descriptors is acceleration, which describes how an object changes its velocity per elapsed time. Since velocity is a vector quantity, we say that acceleration too is a vector quantity. It has an SI unit of meter per second square. Mathematically, we can define acceleration as a is equal to final velocity minus initial velocity all over time. If we are going to look into the equation, we can enumerate three ways to say that an object is accelerating. First, we say an object accelerates if the magnitude of the velocity of object is changing. Second, the object accelerates if the direction of the motion is changing. And lastly, if both the magnitude and direction of motion are changing. It is important to remember as well that acceleration can either be positive, negative, or zero. A positive acceleration tells us that the direction of the velocity and acceleration are the same. Thus, the object is speeding up. If you arrive at a negative acceleration, the velocity and acceleration have opposite directions. This tells us that the object is slowing down. Lastly, if there is zero acceleration, it means that the object is either traveling at constant velocity or it is not moving at all. I have in-depth discussion of this when we talked about uniformly accelerated motion. In our next video, we will talk about average velocity and average speed, which introduces us to the concept of object moving in one dimension only. That is all for this lecture. I am Gilmer De Castro, and see you in the next video.